Find the second derivative using implicit differentiation. All right, well, let's take the first derivative. Take the d dx of both sides. When you do implicit differentiation and you take the derivative with respect to x, you just take the derivative normally for many of these. However, I'm writing and talking at the same time. Right off the bat, I take the derivative of a y value. What you do is you still take the derivative, multiply that 2 to the 4, bring that 2 down to a 1, so invisible 1, 8y. But since we took the derivative of a y with respect to x, we have to attach a dy dx. That's going to equal, I'm jumping the gun here. Take the derivative of 2, gone. So that's going to equal the derivative of 3x squared, drop that down, that is 6 x to the first, and now I have to get dy dx all by itself. So divide both sides by 8y, divide both sides by 8y, and dy dx is now simplified out to 3x over 4y. Okay. Now, the derivative of this guy, all right, so the second derivative is going to be me taking the derivative of this guy right here with respect to x. So this is going to require quotient rule. So I'll call you u, I'll call you v, right? And so I need to find u prime, which is going to be 3. I need to find v prime, which is going to be 4 dy dx. And I need to find what v prime, or v squared is, which is 16y squared. So chain rule, if you forgot, I'll write it up here, is u prime v minus v prime u all over v squared. So let's put it all together. The second derivative, so the second derivative with respect to x is going to be u prime, so 3, times v, so times 4y, minus v prime, which is 4 dy dx, times u, which was 3x, over v squared, which is 16y squared. Now I know something. Okay, let's start simplifying things, but I know something else. Okay, 3 times 4y is 12y, no big deal. Minus 12x, but dy dx, I already know what that is. Dy dx, right here, is 3x over 4y. So I'm going to turn that into 3x over 4y. And that's all going to be over 16y squared. So I have 12y minus, let me see, what will that be? 12x makes 36x squared over 4y. So that is x squared over 4, 9x squared over y minus sign, all of that over 16y squared. So I can maybe do a little bit more. I can pull out a 3, but other than that, I mean, I'm pretty much set. It's not a pretty answer, but, you know, it wasn't a pretty problem. You're not expected to get love and joy when you deal with implicit differentiation twice, product rule, or in this case, not product rule, quotient rule. It's not pretty. It was a lot of fun, though.